We will record it in our club and we will send the link at the end.
inshallah. Thank you so much. طيب شباب, usually whenever we want to analyze a certain system, we have two ways to do it. Either by doing, let's say, experimentation on the real system, on the actual system, or we do experimentation with a model. Again, using experimentation with the actual system, usually when this experimentation is not expensive, not dangerous, we go with it. Okay, such as if you want just to maybe put a door here to maybe to make it easier for the customers or to product to flow in and so on. So this is maybe not expensive action that could be done on the real system. But most probably, and in real life, real complex systems, we usually avoid do experimentation on the real system. So we go for experimentation with the model. We just create model to do the experimentation. We have two types of models, either mathematical models or physical models. For the mathematical models, for the physical models, we just imitate the real system using a physical model, such as if you are building a circuit, electrical circuit with capacitors and power supplies and all of these electrical elements, this is a physical model. Or if we are talking about mechanical engineers, when they just build the prototype for their product or their system, this is a physical model. But usually, or on the other hand, we could build something called mathematical models, such as the one that we know in our, let's say, major OR models are mathematical models, and not a general mathematical models, but we call them analytical models, or we can solve them analytically. Okay, Ohm's law is also a mathematical model that can for sure give us an analytical solution. Usually some models or some mathematical models are very complex to be solved analytically. In that case, we go for simulation. And most of the systems around us are usually difficult to be captured analytically. So we go for simulation in most of the systems around us because of the randomness and the stochastic nature of those systems. Okay. So what is the meaning of simulation? Simulation is just an imitation of a real system operation or real system or operations at a point of time or over time using computer. This is what we had in the examples. We just imitating the real system using a computer. What's the purpose of simulation? Why we build those, let's say, simulation models? Okay, based on the examples that I just showed to you, sometimes you are interested in the utilization of the servers. Okay, what's the proportion of time those servers spend busy over the total time of the shift? Or let's say the average waiting time. Let's say for the passenger. We are trying to minimize the average waiting time. Sometimes we are interested in the expected number of customers inside the system. Sometimes we want to minimize that number and so on. So usually we use simulation to have an idea about the performance measures. Also, we try different scenarios in order to improve those performance measures. Okay, this is what we are doing. We want to improve the system operations. But how to tell if we are improving or not based on the performance measures that we are considering in our system. And if we are talking about emergency room, maybe we are interested in minimizing the waiting time of the patients. In the bank also, maybe we are interested in minimizing the number of, let's say, customers inside the bank, maybe by introducing another, let's say, online system, and so on. Sometimes we use simulation just to design system that is not exist, or try something that is not exist. Okay, we use simulation. And usually we use simulation and avoid experimentation on the actual system when the system is large and complex, okay, cannot be solved analytically or by common sense. And whenever the analysis or the actual experimentation is costly or dangerous on real system. Okay. Any issue, any question? طيب. What's the definition of system? Again, since you are system industrial and systems engineer, you should be aware of the definition of system. System is a collection of entities or objects and resources that are interacting with each other to accomplish some logical purpose or a certain goal. That is examples: manufacturing facilities, banks, hospital facilities, emergency rooms, whatever, computer network, freeway systems, chemical plants, fast food restaurant, supermarkets, and so on. Yani, we show that most of these systems could be simulated for sure. One important, let's say, aspects related to these systems, we can have continuous event system or discrete event systems. For example, if we are talking about the flow of, let's say, the water in a river, or the level of water in a dam, a water dam, this level is changing continuously over time. Each millisecond, there is a change. You see it in x-axis, we have time. And the system state assumed this is the level of the water, okay, behind a water dam. This level will keep, let's say, changing over time. Each millisecond, again, we have different value. In such case, this is called continuous event system. And on the other hand, we have something called discrete event system, such as number of customers in a queue inside the bank. So, or total number of customers inside the bank. So whenever you have, this number is not changing each millisecond. Actually, it changes only when an event occurs. So if we have arrival, the number will increase by 1. You see here, number increased by 1. When we have this increase by 1, when we have arrival. So when we have departure, the number will decrease by 1. When we have maybe 2 departures, the number will decrease by 2, and so on. This type of systems called discrete event system. Clear the difference, Shabab?
Yes.
Yes, Doctor, clear.
Right. Now let us talk about how to do a simulation project. Usually, again, we need to learn about ARENA, but ARENA is coming, let's say, as one step in this full picture. Okay, and usually we will go through, let's say, bank example. Let's say, first of all, maybe the problem that you have in that bank is about the waiting time of the customers. Maybe customers are complaining about the waiting time. They spend a lot of time in that bank. So you just start with problem formulation. Okay. Then you will set up your objective and your plan, how you are going to conduct this project, how you are going to solve this problem. What is the accepted, let's say, waiting time for the customers inside the bank that you want to reach out of this project? What is the software that you are going to use to conduct the simulation? What are the resources that you need to conduct such, let's say, project? Then you start data collection. Data collection, you start collect data about how frequent you receive, let's say, customers. You just record the arrival time of the different customers. Also, you start collect data about the service time. What is the time spent by the cashier serving one customer? What are the different types of customers? Let's say if we have VIP customers and regular customers and so on. You just collect everything related to the system. What is the flow of the customers? Is it one queue or multiple queues and so on? Then in parallel, you do something called model conceptualization. You build your conceptual model. Your conceptual model is nothing but a sketch. You just do on a piece of paper, you just can draw a sketch of the flow of the customer inside that bank, okay? And see a customer arrive first, then they have to take an order, okay? And then they have to wait in a queue and so on. And put the corresponding, let's say, data collected. Maybe 20% of the customers are VIB and 80% are, let's say, regular. Maybe the VIB, they have different track compared to the regular customer and so on. Once you are done collecting data and building your conceptual model, now you have a clear idea about the system. What you can do, you can translate whatever you have in your mind, whatever you have collected, into a model. A model will be built on Arena, on any simulation environment. But in our case, we are building that model using Arena. Once you build your model in Arena, you want to make sure that your model has no mistakes, no issues. You just, if you remember, we started with a model. When I run the model, I end up with an error, okay? How to avoid this error or how to solve the issue? This is called verification process. We need to do verification for the model and make sure that the model is built correctly without any mistakes related in programming and in the construction of the model. And this model is representing the conceptual model, the sketch that we have about the model. This is called verification. So if you still have errors, you have again to go back to the model and fix those errors. Once you are done and you have your model on Arena, okay, then you do something called validation. Validation, just you want to make sure that the model that you built on Arena is a copy from the real system. How to do so? We just compare, maybe assume that in the bank is serving like 100 customers per day, and your model is serving like 50 customers per day. Then it is a huge gap. It means, or it gives you a sign that your model has issue, is not reflecting the actual system. So you want to make sure that you go back. You may need to collect some other data. Maybe you commit a mistake when you sketch the flow of the customers and so on. This is called validation. You want to make sure that the model that you build is representing the real system that you are simulating. Then once you are done, you will do what? You will decide on what different scenarios that you want to try with. What if we increase the number of cashiers by 1? What if we just add one more ATM in front of the bank? Is it going to solve the problem that I have or not? And so on. Then you just do the runs and end up with the conclusions. And maybe if you find your, let's say, the solution, you just document whatever you have and report it to the top management. Then they decide in going to implementation or not. Okay, so that's simple. And all what we are trying to do now today, inshallah, about model translation, how to build your model. And I will give you just an idea about how to, let's say, find the best distribution from the data collected. Okay. Please, Ahmed, you have an issue?
So, Dr. Arena will take place in which step? In the model translation or in the
model translation? You have something in your mind, you collect data about the real system, you just draw a sketch on a paper about the flow, everything. Now you need to translate everything into a computer model. You can use Arena, you can use Pro Model, you can use any logic, any software to translate this, to build your model, actually. Okay. But by the way, everything yani, later, depending on the model that you built here, the model that you have should be verified for sure to make sure that you don't have any issue in the model itself. Also, it should be validated. we want to make sure that this model that we build is representing the real life system and so on, because everything later will depend on this model, the computer representation of the real system. Okay, any other issues?
Thank you.
Most welcome. طيب. Now we will go to this simulation model. When we talk about simulation model, what are the elements of such model? Before we go to the elements, let us define what is simulation model. It's just a computer representation of a real system. This computer representation is built based on assumptions. For sure, you are not able to capture everything 100%. So for sure, you have to put some assumptions. And we try our best to make those assumptions making sense. So it's not very, let's say, strict assumptions or something that will make a big gap between the model that you build and the real system. We try to have, let's say, simple assumptions just to simplify our task, okay, in building the simulation model. Now we go to the pieces of the simulation model. When we talk about simulation model, what are the elements of simulation model? The first element is entities. Entities are the players, and we call them players, an object that move around and change the state of the system. In our bank example, what are the entities there? Customers. Customers are the entities inside the bank. Maybe if we consider emergency room, patients are the entities in that system. If we consider production line, products are the entities. Okay. Also, we have resources. Usually, resources. Those resources are dedicated to serve those entities. Okay, an object that serves the entities. In bank example, bank teller. And a production line could be the machine. In emergency room could be the doctors. Okay. And usually here we have a nice feature, and we will utilize it in Arena now. You will see it. So let me just assume that we have, this is the entity, okay? And we have the server. Entity and server. Usually we have, let's say, entities are waiting in a queue to be served by this server. Usually we use this entity seizes the resource. So whenever the resource is free and we have entity in the queue, that entity will seize the resource. Okay. What does this mean? It means that the server will become busy. He will not be, let's say, available for any other entities. Once the resource being seized by an entity, it will not be available to serve any other entities. They will spend some time together. Okay, so we have some time here for this, let's say, between this entity and this server. So this is called use, or we call it delay. Okay, they spend some time together, which is the service time. After that, once the entity finish, the entity will continue the path, and the server will become free to serve any new entity. So this is what we mean by entity seize. We will see something called seize, delay, release. It means that the entity will seize the server, then it will use it for some time. Okay, so we have delay here. Once done, then the entity will release the server. So the server will be able to serve another entity, and the entity will proceed to the next, let's say, step. This is very important concept. We will see it now in Arena, inshallah. Okay. And we have state of resources. We could have idle or busy or not active. What's the meaning of idle? Shabab?
Not working.
Yeah, the server is okay and ready to work, but there are no entities to work on. So this is idle. Busy, you know what is busy. Not active, maybe under failure or for any other reason. We could have set of resources or a single resource. Okay. طيب. I know that we promised that we have breaks. Let us finish from the presentation, then we have our break. It could be maybe more than 10 minutes, so don't worry. Okay, Shabab?
Okay.
طيب. Another thing is called attributes. Okay, sorry. Attributes. What's the meaning of attributes? Is a local variable, or we call it a sticker. When you have a lot of stickers, you know the meaning of sticker, okay? And this sticker is used for entities. So just to give a property for the entity, or just give it some characteristic of the entity, or description, or to differentiate entities. In our bank example, okay, we could put stickers on all customers to distinguish between VIP and regular customers. So whenever I receive an entity, I'll just attach certain sticker on that entity. I give it a name and give it a value. Maybe I give it a name of, let's say, sorry, I forget to bring my tablet to write, so I'm using the mouse, so things are very bad in drawing. So if we have an entity and we just put a sticker on that entity, and we may call this one as type or T, and T could be VIP. Okay, VIP. Again, it's very difficult to write using the mouse, so I just want to highlight the idea. Maybe another entity, we give him another sticker. Again, the sticker called T, again, the same name of the sticker, but this guy is having a value of R, regular customer. So this is both entities having the same sticker name, which is type, but they have different values. This is called attribute. If you just remember this sticker, you will understand it well. So examples, we could differentiate entities using their time of arrival. For each entity, there is different time of arrival. So for sure, the name of the sticker will be time of arrival, but each entity has different value of time of arrival. Again, maybe for priority, I may name a sticker by priority, maybe critical patients and non-critical patients. So later, if I want to distinguish between them in the middle of the model, I can just look to that sticker and tell who is critical and who is not critical. Okay, or maybe differentiate using color. Okay, this color is red, the other one is different color, and so on. So, but the important thing here is just to know that we are using attributes or those stickers just to distinguish between the entities. So later I can just pick up maybe the VIP customers and keep all other regulars for, let's say, different stage and so on. طيب, we have something called variables. From the name, variables, something is changing over time. Okay, those variables are reflecting the characteristic of the whole model, not a specific entity. Now, those variables are not related to entities, they are related to the whole model, such as number of customers inside the model, inside the system. This number of customers is changing over time. Yani, if we have arrival, if a new customer arrived to the bank, what will happen to the number of customers inside the bank? Will increase by 1. If one customer just departed the bank, the number inside the bank will decrease by 1. So the number inside the bank is a variable affected by events. Let's say the status of the server, is he busy or idle? So it's variable as well. So if we don't have entities, the status will be idle. If we have entities in the queue, the status will be busy. Okay, So those variables are changing over time, but they are not changing continuously. They are changing in a discrete manner. Actually, most of the systems that we are talking about here and Arena is just a discrete event simulation software. So we are considering this type of systems. Okay, we are talking about the discrete event systems. This is, most of the systems that we are handling here are discrete event systems. We are not touching anything related to continuous event systems. Okay. Now, yeah. So here used for many different kind of things: travel time between all station pairs, number of parts in the system, simulation clock. Because yeah, simulation, we are doing simulation over time, so the clock will keep moving. So yeah, this is considered as built-in Arena variable. Another thing to be aware of, the queues. We know that if you go to any system here in the bank or in a supermarket, and you go to the cashier, okay, or to the teller, you have to wait in a queue if it is, let's say, if the server is busy. So place for entities to wait when they cannot move on. Maybe since the resource they want to seize is not available. So maybe you have to wait, for sure, you have to wait in a queue whenever the resource is not available, busy with another entity. Okay. A queue ranking here, how is the discipline that the server, let's say the discipline of service, okay? What is the criteria of picking up entities from the queue by the server? So first in, first out, similar to clinic, sometimes in bank. So who come first will be served first. Or we could have last in, first out, such as goods and inventory. When you just go in elevator, who come first will leave first, because you will be inside the elevator, and whoever come later will be near to the door of the elevator, and so on. This is last in, first out. Or could be based on attribute. Could be you will serve maybe VIP person first, you will serve the critical patients first, and so on. So we said that attributes are properties of entities, so you can use it to decide on the service discipline or queue ranking. Okay, so that's it for our introduction. Any questions, Shabab, related to these elements? Please. Any question? Any issues?
I think all clear, Doctor.
Yes, Doctor, I have a question.
Okay.
بالنسبة لل SPT إيش معناه؟
SPT, shortest processing time. Where it was? Let me just. I don't know what happened here. Yeah. It's not here, but yeah, in your slides, is it here?
No, in the slides.
Shortest processing time. يعني تأخذ أقلهما وقت على الماشين.
Okay.
Okay. So inshallah, if there is no question, we will take a break. So you know now these things, you should keep it in mind. By the way, those elements are very important when we go to our exercises, Yashima, okay? So yeah, I think we can take a break of, still we just have 50 minutes, yeah?
I think for the break we have like 2 minutes, because we started at 6:10.
Yeah, 6.
At each 50 minutes we will take a break.
Yeah, no issues. We will be flexible. We will not be that strict.
Okay.
So we will come back at 7:10. Okay, because we need to proceed. Whenever we just start, let's say, part, we need to complete it till the end.
Okay.
So yeah,
So
I think at 7:10 we will come back, Yashaba.
Doctor, can you upload
Yes.
the slides?
slides. It's not, by the way, you will see that it's just 2 exercises. You have it in your lab. Okay, so yeah, once you install Arena, okay, you can just search for it here and you will find it, or it will be in the inside C program files. You will find it under Rockwell software. You will find Arena icon, and you just click on it and you will open it. Maybe the confusion come with maybe this new version of Arena. Usually this was not there, this version. We had an older one with different, let's say, interface. But this one, let's say, have a new, some new features. But usually I prefer to use the older, let's say, structure. And let us have just a look on the different, let's say, elements of the interface before we go with a new model. Okay, so here we have home, similar. They just change it to be similar to Microsoft Office, Word, or Excel. They have the same feature. Here you have home where you can just copy paste, you can just connect the different modules, you can just do the run from here and so on. Also animate, whenever you want to do animation, you can just come here and choose the proper module from here. And also you can just do some drawing, just if you want to do, let's say, this represent certain, let's say, section, and you want just to do drawing. This drawing has nothing to do with the model, just as part of, let's say, organization. Maybe you will build something here inside this box, and just you use documentation. You can just also add text. Okay, well, sorry, here you can just add text, and so say this is representing machine 1. Okay, whatever, those are just for decoration, has nothing to do with the model. Still, we did not touch anything related to the model. So here you want to build the process related to machine 1 and so on. This is just for drawing, so it's not our focus now. Run, here you can just decide on the running parameters. Okay, run, stop. Also, you can just do the setup for the run. We will come to that part soon. Okay, how many replications, what is the replication length, what is the base time unit, and so on. And also what kind of, let's say, do you want to see the report at the end or not? Parameters, what kind of things that you want to show in the final report. Okay, also we have here view and some tools. We will use one of these. We will come to this part and we'll use one of these tools. Yeah, that's it. Also here we have the modules, the different modules that we will use, or blocks that we will use to build our model. Okay. In order, I know that some of you will not have those 4, let's say, bars are from the old version. Okay, the new version only have this data definition, discrete processing, decisions, grouping, and so on. You can just use it directly from those new version bars. But also for me, it will be more convenient, because I used to use these modules. I will use those ones, the older ones, even though it is already there here. You can just find it. Discrete processing, you will have here create. You see here you have a create. Also here from basic process you have a create, the same create. It's up to you which version you are going to use. And if you don't have those bars, the older ones, you can just come here into any empty space and right click, okay? Right click, then you have template panel, attach. Template panel, attach. Then you can just add the bar that you want, okay? These are the all bars: advanced processes, advanced transfer, and basic processes, and so on. These are the old ones. Okay, here old arena templates. You see, it's from templates, old arena templates. Those are the old ones. You can add it. We will use this basic process and advanced processes, advanced transfer. You will use it, by the way, in the course. And you may use statistics. Okay. طيب. So this is the interface. Okay, shall I close? Let us keep it open. So here, when you want to build your model, you just need to create or to choose the proper module, okay, and just drag it here. Then if you have another thing, maybe process, drag it here, dispose, drag it here, and then you can just connect between the different, let's say, modules using this connect. You just click here and connect the different modules to have your model ready. But yeah, we will go through this. We will go through this using our exercises. So let's go to the first exercise. Any question related to the interface here? What are the elements that we have in Arena in general? And if you have missed, let's say, one of these bars. Fine. Let's go to the exercises. Let's start with a very simple exercise. Here we have, this exercise is about a factory produces electronic devices, let's say microphones and headphones. The factory implement a quality control system. Again, here the exercise about the quality control system or department. We are not focusing on the whole production line. We are just focusing on the quality control system, that department exactly. So here the arrival of microphones, okay, to that department, which is the quality inspection center, at a certain rate, and here the inter-arrival time for the microphones following exponential distribution with 20 minutes. Then those, let's say, microphones will be inspected by inspector, and this is the service time for that inspector. That inspector will take uniform distribution with minimum 5 to 8 minutes, okay, to, let's say, serve a single microphone. We need to create a single server model in Arena with the following, data. We need to run the model for 5 days, 8 hours a day, and the base time unit in minutes, okay? And we need to do 30 replications. So usually, let's go to Arena model. In any model, we need to use those two, create and dispose. This create from basic processes or from discrete processing, okay, you will find here create and dispose. Those two are very important for, and it will exist in all models. So create, and we have something called dispose. What is the use of those two modules? Create, we just identify the arrival of the entities, how entities going to arrive to our model. Again, here we are talking about a production line, so we are talking about microphones arrivals. Okay, maybe we could talk about patients arrival, maybe customers arrival to a bank, and so on. Okay, so it will define the arrival process of entities into the system, and this dispose like the door at which entities are leaving the system. And anything in between those two, is considered as the system. So this is like a door that from which entities are entering the system, and this disposes also another door from which entities are leaving the system. Okay. Now, since we have only one operation from here, we are talking about just about the quality inspection center. You see that we have only inspector. So we are talking about single server model. So whenever we have server and service, okay, it could be a machine serving entities, could be operator serving products, could be doctor serving patients, could be teller serving customers in a bank. We are using process. You see this one process, we just drag it here inside. Okay. So once we have this process, before we go, yani, okay, so we can just connect those arrivals. We'll go to the process for the inspection. Then product will leave that inspection center. But now what to put inside each one? Let's go one by one. For create, here we are talking about microphones arrival. Okay, using this is just the name. What will appear here in front of you in the model? Just the name that will appear in the module here. Then what is the name of the entity that will be created by this create? So here we are talking about microphones. I'll use mic. Okay, so any entity coming from this create will have a sticker, called entity type, and inside that one has a value of mic. So whenever I want to check what is the entity type at any level of the model, I can just refer to that to that sticker. Now, time between arrivals. Again, this is called time between arrivals, not the arrival rate. It's about guys, you see my screen, yeah?
Yes, we see.
Okay.
Screen.
Okay, good. Type. So here the time between arrivals. What is the time between the consecutive, let's say, arrivals? What is the time between the customer and the next customer? What is the time between this product and the next product? Okay, and this feature represented by distribution. You can use any distribution. Okay, you can just say expression and use any distribution. How you can do that? You can just right click here. There is something called build expression. So whenever you are not familiar with Arena and you don't know what is the expression to use in these, let's say, blank spaces, you can just go to build expression. Okay, it will give you everything included. One of them is mathematical functions, okay, min, max, whatever. Sometimes you need to use it. Okay, here we are interested in what? Random distributions. Okay, I want to use, let's say, normal. If I want to represent this interval time by normal distribution, I can come here and search for normal distribution. So here we have normal distribution. You just click on normal, and it will give you what are the parameters of this distribution, mean and standard deviation. So you have to put the mean and standard deviation. Okay, so you can write it like this: norm of the first value will be the mean and the second value will be the standard deviation. But in our case, we are talking about which distribution? From here, it's following exponential distribution with mean of 20 minutes. Okay, so the arrivals, we go back here. Where is exponential? Here, exponential. And sorry, let us remove everything here. Exponential. We are, again, we are using boson. Let us remove everything. Exponential. Okay, this is how we write exponential distribution. And between the parentheses, we have what? The mean, not lambda, 1 over lambda. So in our case, what is the mean? 20. Anyone can tell me what is the meaning of this expo 20? The end time between arrivals is exponentially distributed with mean 20 minutes. Anyone?
The average waiting time will be 20 minutes.
It will be the time between two consecutive arrivals. Yani if I receive one microphone now, when I will expect to have the next one? Around the 20 minutes. Yani in 1 hour, how many arrivals I could have?
About 3.
About 3, exactly. But here, since it's following exponential distribution, it could be 20, it could be 19, it could be 18, it could be 15, based on this distribution. But you know the idea now, okay? Any issue, ya shabab, regarding this?
Clear.
طيب. Also here we have, yani, instead of doing it this way, we have this random expo. So if we are just exponential is the only one here because it is a special case. Usually in queuing theory, most of the systems with interarrival time exponentially distributed, they have analytical solution for it. So this is why we have a special case for exponential, and we know that exponential distribution has this memoryless property. So this is why when the arrivals are totally random, it's almost following exponential distribution, and we just need to put the mean, which is 20 minutes. Okay. Here, entities per arrival. So do we have 2 entities whenever we have arrival? Is it 2 or 5 or 1? In our case, it's 1 microphone only.
Or only one.
Okay. Maximum arrival sometimes, if we are just talking about maybe some systems, and you know that the maximum arrivals for mics will be 150, you can just put it here 150. But since we will use run setup to identify the stopping criteria of our simulation, so we will keep this one infinite because it will stop once we tell the model to stop. Yani after 5 days, we have to stop the model. So this one is not important at this stage. Okay, so we keep it infinite. First creation. At what time you want Discrete to be activated? At what time you want Discrete to start producing entities or introduce entities? Sometimes you have multiple creates. Yani sometimes you have maybe create for critical patients and another create for regular patients, okay, or non-critical patients. Maybe critical patients will not arrive at the beginning, maybe after 1 hour. And after 1 hour, or 1 hour means maybe 60 minutes. After 60 minutes of the starting, from the starting of the simulation, this create will be activated and start introducing entities or producing entities. Okay, so when we put it like 0, it means that whenever we start running down the model, this create will start introduce entities and produce entities to the model. Okay, clear?
Can you repeat the last point?
The last point, this first creation, when do you want this create to be activated? Okay, when do you want this create to be activated? If you write here 60, what does it mean? It means that when we pass 60 minutes, this create will start creating mics. Okay, we'll introduce mics to because we call it microphones. Okay, to the system. So for the first 60 minutes, nothing will generate from this create. And after 60 minutes from running the simulation, it will start creating the entities. If we just put here 120, it means that I will start running the model. Okay. After 120 minutes from the start, it will I can see some mics going out from this create. Before that, this create will be on hold. Clear?
So it's not like the usual starting from time 0.
You can exactly. The default is 0. When we go for this 120 or 60 or whatever, whenever you have, let's say, multiple creates, okay? For example, let me show you here in cancel. I missed one of the examples here. This one is supply chain one, okay? And this is the level of inventory in the supply chains. You see that there is a demand on this warehouse, and there is reorder point, and you can see the manufacturers, and you can see the suppliers, and you see how the inventory is changing. You see that whenever they reach a certain reorder point, they will order from the manufacturers, and the manufacturer will provide the required material to the warehouse. You see the decrease here in the manufacturer's inventory. And once those manufacturers also reach to a reorder point, they will order from suppliers. Okay, so this is another example, but here I want to show you that we could have different creates. Maybe for manufacturer 1 we have one create, and for manufacturer 2 we have different create, and so on. Okay, the idea here, if I have different creates, okay, and I want one of them to be active, maybe I will run this simulation for 1 year, okay? And at the beginning, only supplier 1 and supplier 2 are available. Okay, Shabab? So if supplier 1 and supplier 2 are available, and maybe I will put here, maybe after half a year, let's say how many minutes or hours here, if the base time is hour. And you can just put here first creation at let's say 100 hours. It means that nothing will be created from this create till the 100 hour. Before this 100 hour, nothing will be created from this create order MS arrival 3. Okay.
Clear.
Doctor,
Yes.
for the max arrivals, what is the function for that? And why we put it as an infinity value?
Infinity, why? Because just صبرك علي ثواني, لأنه we will go, when we go for run and we identify the setup, okay, replication parameter, we will see for how long we want to run this model. We want to run it for, let's say, replication length 5 days. Each day is 8 hours, okay? So after 5 days, this system will stop. Okay, so I'm not care. I will keep, over the 5 days. I don't want to have a cut here. If I just put here 10, what will happen? Oh, we lose this. Shabab, if I put 10, what will happen?
The system will terminate.
After 10, yeah, it will introduce 10 only. Those 10 will be processed. Yeah, once it is done, yeah, the model will be terminated. Okay.
Okay.
But if we just keep it infinite, okay, it will make sure that mics will keep introduced to the system, will keep arriving to the system, okay, and the system will be terminated. The model will be terminated based on the run setup. Okay. Okay, Shabab. Any other question related to create? Again, create is just the door. How we are going to receive our customers, our entities inside the model. Right. Now, once it is one entity arrive, it will go to the process. And this process, what we call it, this is called equality inspection. center. Okay, this is quality inspection center. This is the name that it will show here on the module outside. You see it used the name that we wrote. Okay, now here the logic we have. You remember seize delay release, delay release. You remember what is the default one that we are using? Seize delay release. Okay, why seize delay release? Anyone can tell me? Here we want to identify the inspector. So whenever all entities, arriving entity will go to the inspector who is located in the quality inspection center. طيب, what is the service, let's say discipline? Anything in the chat? شباب. Okay, so seize delay release. Why seize delay release? Because any mic will seize the inspector. Okay, what's the meaning of seize? احتلال. Okay, it will seize the inspector, so the inspector will not be able to serve any other mics. Okay, then they will spend some time delay. They will spend some time, which is the service time. Then the mic will release the inspector. The mic will proceed on, and the inspector now will be free to serve any other mics. Clear, ya shabab?
Yes.
Yes.
So this is seize delay release. But if you just use delay, you see whenever you use delay, there is no resource. Why? There is no resource to seize. Okay, it will be just a delay. The entity will stay here for some time, and it will move. So, and what's the capacity of this process too? It can accommodate. This is like self-service, infinite capacity. Okay, you can serve maybe billion of entities at the same time, but because there is no resource, each entity will arrive to this entity. Each entity will arrive to this module. This process will spend some time, the time that we put here. But in our case, whenever we are dealing with servers, it is seize delay release, and you know why now. Right, now we need to add the resource. You remember we talked about resources, so we can here add resource. So you add the name of the resource. What's the name of the resource? We know that the name of the resource is inspector. Right, and this is here very important. Unit to seize release. Anyone just can guess what is this number?
Is it number of servers that's available in the system?
Actually, believe me, this is the default answer, and most of the students in the lab exams they commit a mistake in this one. Yeah, actually, this is not the available inspectors. It is how many inspectors will be seized by a single mic, okay, or a single customer. If you put here 5, it means that each single mic will occupy 5 inspectors. So if you have less than 5 inspectors, you will end up with an error, because each mic needs 5 inspectors at the same time to work on it. Clear?
So we mean by that 5 labor to process the one for one mic.
Exactly. Okay. So if you just keep it 5, it means that you need 5 inspectors to serve a single entity. But in our case, we need just 1 inspector to serve a single mic. Yeah. Guys, if you have any issue, please just let me know. Now, let's go to the processing time. Now, what is the time here? What is the delay? What is the time that the entity keeps seizing this resource? Now you have some distribution. It could be normal, triangular, uniform. By the way, why we have those distribution? Because in real life, nothing constant. Everything is random. Okay, and when you go to real life, for sure you need to just collect data and identify the proper distribution for the service time. In our case, it's given here. The service time is following uniform distribution with minimum 5 and maximum 8 minutes. Anyone can tell me the meaning of this distribution?
So the service time will be between 5 to 8 minutes.
Exactly. And it's totally random. Yani, all of these values are having the same probability to be selected. Yani, it could be 5, 6, 6.1, 7.3, whatever. Okay, but the minimum will be 5 and the maximum will be 8. Okay.
So uniform just to specify the upper and lower limits.
Yes, and
or the minimum and maximum
yeah,
service time.
Yeah, but in general, let's say for mic 1, it could take any number between 5 and 8. It could be 7.3333. Okay, could be 5.01 minutes and so on. Okay, because this is the continuous uniform distribution, not the discrete one. Since we are talking about service time, with service time, whenever you are talking about time, it is a continuous measure. صح ولا لا?
Yes.
Okay, so this is what we have. طيب, once done, خلاص, this is the process. We identify the server, we identify the action, seize, delay, release. You will see that once we identified as seize, delay, release, we will have a new element, which is the queue, will appear here. Because whenever entity arrive and find that inspector busy with one mic, that mic will keep waiting till the inspector become free. طيب, so that's it. So okay for this.
Doctor,
Yes.
seize, can we assume it like if an entity being seized, is it like it's in the queue, in the waiting list, for example?
Entity being seized, by the way,
Yeah.
this is one thing that you want to know. The entity will seize the resource. يعني انت لما تروح على بنك ككاستمر، انت بتحتل اللي هو التيلر وبتخليه مشغول معك لفتره معينه، بعدين انت لما تخلص انت بتطلق هذا اللي هو السيرفر، اوكي، عشان يخدم حدا غيرك وانت بتكمل. فالسيز هنا جاي من الانتيتي. entity will seize the resource, not vice versa.
Yeah, clear. But I mean for the not the served one, the another entities are waiting.
We don't have to interfere, by the way. We just put the main structure. خلاص, this randomness will be captured by the software. احنا at the end we just give those distributions. Why we don't do it manually? Because it is a very complex to be analyzed manually or analytically. So this is why we need simulation. This is very difficult to track, by the way, one by one. And this is why we do many replications to make sure that we are statistically in the safe side. All of these details will be handled by the software, by the way. You don't worry about it. You just put the main structure, then you just run the model. I don't know
Okay,
if I got
yeah.
Yeah. So you don't have
Thank
to worry
you.
about this. You will see it now. Just a moment. So once we are done from the process, خلاص, dispose here. Leaving the system, or I'll keep it like dispose. خلاص, dispose. Once it got or it has been served, it will be it will leave the system. Ahmed.
Doctor, what is the meaning for this number behind the quality inspection center box? There is a 0.
You will see it when you run the model, how many entities pass through this module. Okay.
And what is the function?
Yes.
And what is the function for dispose?
No function. Dispose is just a door. Yani, if you just keep entities without door to leave from, if you just remove this one, what will happen? entities will keep accumulating here. Okay, so you have 1 million entity here, but the logic says that whenever you serve an entity, it will leave the system.
So it's like a storage.
Not a storage, it will be like leaving this خلاص, it will leave the system. This is door at which the entity will leave the system. يعني زي الكاستمر لما يطلع من البنك خلاص مالوش دخل في اي شيء داخل البنك.
I got it.
Okay. طيب, now once we are done, let's go for the setup. Let's see how to do the setup. Here you, for the run setup, before you are doing run setup, you can go to run. Okay, and from run here we have run setup, and from setup we have replication parameters. You have to tell how many replications you want to do. It's from the exercise, we need to do 30 replications. And if we have warm-up period or not, no, we don't have. Remember that we have to do it for 5 days, 8 hours per day, and base time unit in minutes. Okay, this is very important, ya shabab. So we will run the model for 5 days. Each day has 8 hours. So in total, how many hours?
40.
So it will, if you just write here 40 hours, it will be the same, exactly the same. فاحنا instead we just say 5 days. 5 days, each day has 8 hours. Yeah, and this is very important. You see here base time unit. Okay, base time unit, either hours, days, minutes. It says choose it as minutes. Why this one is very important? Let me show you. Okay, if you choose it like in minutes, in many modules you have spaces to write maybe time. Here, if you use minutes, you have to put it in minutes. Assume that I want discrete to start after 1 hour. I cannot write here 1, because 1 will mean 1 minute. So 1 hour means 60 minutes. Okay, because the base time unit here we choose here is minutes. So if I want 2 hours, I will write here 120. But if the base time unit here is hours, when I come here and write 1, it means what?
First entity will create after 1 minute.
1 minute or 1? I choose the
1 hour.
1 hour.
1 hour.
Yeah, because I choose here hours. So clear?
Yes.
So whenever you choose the base time unit and you have empty spaces, okay, and those spaces are related to time, and there is no specification like this one, you decide if it is minutes or something else. Here there is no specification. It will choose the base time unit. Okay, if it is in minutes, you have to write it in minutes. If it is in hours, you have to represent it in hours. Yeah.
If I want to make like 2 mics going on the same quality inspector center, can I do it or not?
To what?
2 mics. For
Okay.
example, 2 mics.
You want to serve 2 mics
at the time,
at the
yes.
same time. We will come to that part. Just a moment. We are taking here. We have here. You see here basic processes. We have the modules, and we have here something related to resources, the queues. If you just click on resources, you will see that the one that we added to the process, which is inspector, is here with fixed capacity. We can play with the capacity. If we just put here 2 inspectors, if you just put 2, it means that you have 2 inspectors. So those 2 will be able to serve 2 mics at the same time. Okay?
We specify that the mics goes through 5 inspectors.
You want like in series, 5 inspectors in series or in parallel?
No, in series.
In series, you just need to do what? Bring another process. Where is it? This process. Okay, another process and another one, and so on. and this
okay,
process
okay,
will
I
be
get it.
inspector 2.
I
Okay,
get it.
sees delay release. We add this one now, not inspector 1. I'll call this one inspector 2. This is a new resource, and so on, and put the inspection time for the second, let's say, quality characteristic, and so on. Okay. طيب احنا still we are on basics يا شباب, how to run very simple model. Yeah. Who else? I saw some. Yeah. Ahmed,
Yes,
still you? Yeah.
yes, Doctor, for the process we add the value for the max as an infinity, and in the setup we set it as 30 replication. So this process will repeat it 30 times, or after 30 items it will end.
طيب, let me tell you something. By the way, this is out of the scope of this workshop, but again, just since you asked the question, if I just do one replication for 5 days and 8 hours a day, yeah. By the way, the best time in minutes. Do you think, again, since we are dealing with stochastic input, what about the output? It will be stochastic. It will be a random variable. صح ولا لا?
Yes.
Okay. Usually, when we do simulation, we do it for very long time, because to capture the whole statistical feature of the system. انت الان لما تروح بدك تسوي sampling, لو اخذت سامبل واحده كافي تسوي عليها conclusion. رحت لpopulation and you just assume that KFBM population, and you want to check the average GPA for students of KFBM, and you just pick one student. Is it enough?
No.
No. So you do maybe like 30 students, and if you take the average of 30 students, it will give you an idea about the average GPA of KFBM students. The same idea applied here. Again, later you will if in the course we will discuss this in chapter 11. So don't worry about it. But at the end, you need to do some replications.
Thank you.
Okay. But the general idea, you can just compare it with the example of this population and sampling. If you just take one sample of size 1, it is not statistically representing the population. Got it? Yeah.
Yes.
Fine. Once we are done, then you can just run the model. Here you can just run it, and it's very, very fast. You see now, you see that those mics are going. You see 31, 34 here. Whenever you see here one or how many under this, let's say, process, and how many pass through this dispose, and how many created by this create. Okay, Shabab? Whenever you see one mic up, it means that that mic in the queue, because the inspector is busy with another mic. Okay. طيب. Now, yeah, I think that's it for this part. Now, we have some questions here. Okay. Once you run the model, you are not interested in seeing maybe the animation. You can just click on this batch run. Oh, sorry. And you can just avoid the animation. Here the number of replication 30. Okay, done from 30. Okay, why we don't see the report? Because here there is an option for, maybe some of you will face the same issue. If you don't see the report, go to run setup reports, always showing, prompt me, just ask me if I want to see the report or not, and or keep it never. So I will put here prompt me. Okay, so we just run it without animation. Okay, so yes, you see, do you want to see the report? Yes, I want to see it. Again, we said it will show you how many number out in total during these 5 days, we served like 118 microphones. طيب, in the report, how to read the report يا شباب? We said that whenever we do simulation project, we are interested in the performance measures. Performance measures are related to entities. Okay, yani sometimes the waiting time of customers in the queue, the total waiting time in the system, maybe the expected number of customers inside the system, and so on. So entities in our case are mics. Okay, so here if you just click on entities, you can see if you are interested in performance measures related to time, you can just click on time. Others related to numbers, you see. Okay, so time, value added time, this is the total time inside the system, which is 6.49 minutes. Okay, and the waiting time, this is the expected waiting time inside the system for a single mic. Okay, so the waiting time, by the way, this is, sorry, I'm sorry, this is my bad. This one is not the total, this is the service time. So the expected service time for mics is 6.5, which is yani, reasonable, because we use uniform distribution between 5 and 8, and the uniform 5 and 8, what's the expected value of that uniform distribution? Will be 6.5. So on average, each mic will take this amount of time, 6.5 minutes. And on average, this is the waiting time of any mic in the queue, 1.4 minutes. The total, the summation, you will get the total time inside the system. So on average, this is the total time spent by each mic inside the system, which is 7.9. Maybe as an analyst, you want to minimize this one. Maybe if you add one more inspector, for sure, this waiting time will be decreased and the total time in the system will be decreased, and the total output also will increase. Okay. Also related to numbers, a number in, total in, and number out, and web. On average, how many mics are there at any given point of time? On average, we have 0.4 mic. Again, it does not make sense for you, but statistically, it does make sense. It means that sometimes we have 0, we have sometimes 1, we have a maximum value of 5, but most probably the system will be empty because this average is very close to 0. Now, if we are interested in something related to resources, maybe we can tell, if we can click here and see what is the utilization of the resource. We see that the utilization of the resource is 0.3, yani 31.95%. Yani 1/3 of the time, the inspector will be busy, and 2/3 of the time he will be idle, doing nothing. So we can assign him maybe some more tasks to increase the utilization, if it is not okay with us as management. Okay. طيب. So let us answer those questions, ya shabab. Here we have some questions. So on average, how long did microphones spend in the model process? So we are talking about the total time. So we go to the report. We are talking about microphones. What is the total time? It is 7.9. Okay. On average, you see that our output also is random. We have half width. You remember the confidence interval from 315? I see 315. This is like a confidence interval. We are 95% confident that the true, let's say, a total time is located between this value plus minus this value, this half width. Why? How we got this half width? Because of the number of replications that we did. We did 30 replications. And here it can show you the minimum average, the maximum average. This is among the replications. the minimum value, the maximum value. So in all of these 30 replications, one mic spent this time in the system. It means that this mic spent 5 minutes under service and nobody was in front of him, so he started service immediately. And in another case, we have maximum value is 25. One of the mics over the 30 replications spend this amount of time, 25 minutes point something. It means that maybe this mic got 8 minutes as a service time, and it has like two other, let's say, mics ahead of him in the queue, ahead of it in the queue. So it takes that much time. So, but in average over the 30 replications, this is the average that we have. Okay, Shabab. Now, for what was the longest time a microphone spent in a service? Yeah, what was the longest time a microphone spent in a service? Now we go to the maximum. So over those 30 replications, okay, just a moment. There is a call, but it's not appearing here.
Do you want us to stop?
No.
Okay.
There is a Teams call. Now it disappears. Okay. So let us go back. Yeah. So Shabab, those averages for the replications. Yani in each replication, we have around 100 something microphones processed. Okay, and these are the average total time for the 100 microphone. And one of the replication, this is the minimum. Among the replication, this is the maximum. And for this one, for this one and this one, for all 30 replications, for all mics in those 30 replications, this is the minimum total time in the system, and this is the maximum inside the system. So it means that one of the mics got this value and another mic got this maximum. And all other mics in those 30 replications are having times between those two values. Okay. So to answer this question, what was the largest time, the longest time a microphone spent in the service? So this is the answer. Sorry, this is the answer. Maximum value 25.35. Yeah, 25 minutes. Let's go to the next question. What was the maximum number of microphones waiting for service? So what was the maximum number of microphones waiting for service? This is something related to the queue. So we go to the queue. I'm talking about time or others. I'm talking about number. So I'll go to other. Okay. Number waiting, we will see that, okay, this is the average waiting as number. So on average, we have 0.07 mics, okay, waiting in the queue on average. But it happens one time we find that we have 4 mics are waiting in the queue. And some other times we have 0 in the queue. This is the maximum and this is the minimum. Okay. What proportion of time was the inspector busy? We are talking about utilization. Okay. Utilization. So we go to resource. The inspector is the resource. We go to the usage of that resource. So this is the utilization of the server, the percentage of time he was busy over the total time. So, or from the 8 hours, he's working 0.319 out of the 8 hours. Okay, just if you multiply this number by the 8, you can tell how many hours he spent busy per day. Okay, Shabab? Shabab, any question? Any issue?
واضح دكتور.
Fine. Now, for you as an analyst, again, I told you, you can just check one thing. in this model, you can just come back to the model. You just close this, or no need to close it. We go back to the model. Assume that we want to add one more resource. Assume that we will have 2 inspectors. What do you expect now? What will happen to the waiting time? What will happen to the utilization?
Less waiting time, more mics
Yeah.
will be inspected.
But what about you see, we serve more entities. So you see the total time was 7 point something. Now it is 6.6. Why? Because the service time keep the same, but the waiting time it decreased. Okay, it was 1.4. Now it is 0.11. What do you expect will happen to the utilization? Shabab? Increase or decrease? Shabab? For sure decrease, because now we are not having one inspector, we have 2. They will take like less, let's say, busy time for each one now, because the work is distributed in those 2. Okay, Shabab? Okay, type. So I think we need to proceed, but yeah, it's good to take a break now. Let us make it like 5 minutes, and we will just proceed. Okay.
Okay. I will stop recording for now or pause
Okay.
it.
Ahmed, are you there?
Yes.
Okay. I think we can restart or start recording again.
Yeah.
Okay.
Just resumed.
Okay, Shabab. Now let's go to the next part here. We need to create another type of devices, headphones, okay, which has exponentially distributed inter-arrival times with mean of 30 minutes. Assume that the same service time for microphones is required by the inspector to check the quality level of the arriving headphones. So we need to add one more, let's say, type, which is headphones. So I'll go for basic process. I can use another create here, okay, and this create is just for headphones arrival, and each one of these will be, I'll just name it okay, let us name it headphone. Okay, each entity coming from this create will be headphone, and the inter-arrival time is exponentially distributed with mean of 30 minutes, and the same infinite maximum arrivals, entities per arrival 1, and first creation is 0. Then I have to, from here, from home, just connect the headphones to the inspector, okay? Since they are having the same service time, so I just connected directly to the inspector. We forget to bring it back to 1. What do you expect now will happen to the waiting time and for the mics, and what will happen to the utilization of the inspector? Shabab. What do you think? Any volunteer? Shabab, are you with me?
Yes, doctor.
طيب, what do you think will happen to the total time in the system, or the waiting time for mics? We just introduced a new type, which is headphones. What will happen to the waiting time of mics? Is it going to increase or decrease?
I think increase because we added a new item.
Okay. What about the utilization of the server, of the inspector?
Also increase.
Well, sure. So you will see that here, and you will see that the total time for mics now is 10 instead of 7 point something. You see here, because the waiting time increased from 1.4 to 3.8. And if you just look to the utilization, the utilization is increased as well, because we add more load on that inspector. Okay, that easy. And this is the beauty of simulation. It can give you let's say results of different scenarios. Now, part C, for animation enhancement, we need to select different pictures for different devices. So how to assign, let's say, different pictures, one picture for mics, another picture for headphones, for the animation. Here, as you see here, we have resources, we have entities, attributes, queues, anything related to the model. So here we have entity. Under basic proceeds, we have entity. We can see the two entities that we have, mic and headphone. And here we can just pick up an initial picture for those. I'll use let's say I'll use blue ball for mic, and I'll use red ball for, where is it? Yeah, red ball for headphone. If you just select those two pictures, then, and we go to run, and just disable dispatch run so we can see animation, and we run it, you will see that each why we see, let's say, more red balls compared to blue ones.
Takes less time.
Based on the time, interval time is here 20, here 30. What do you think about it? Which one's supposed to be more? Shabab.
Mic.
When the interval time here is 20, and interval time here is 30. Blue or red? We said how many mics we could receive in a single hour. Here, when the interval
3.
What about here? How many? 2. So we expect to have blue supposed to be more than the red. You see, if you run it for a shorter time, things will not appear clearly. But if you run it for a long time, you will see that for sure this mics should be greater, or the number is larger than the number of headphones. This is how you, let's say, verify and make sure that your model is correct and there is no error. Okay, Shabab? طيب, we are done from this one. Let's go to the next. Modify the model by inserting a decide module between the process module and the dispose module. select option two-way by chance and give 80% 80% true option. And yeah, we will do this. Assume that we want to split. This is dispose and this is another dispose. Okay. Assume that we want to split entities in two different paths. Okay. Assume that we have maybe 80% are good and 20% are bad, and this is the good items store, and this is the bad items store. By the way, we are not maybe interested what is going on after this stage or after this point. So we can split them. If I know that 80% are good, I can just add something called decide. You see here, basic proceeds, we have decide. You can just bring decide here, and we just connect it with quality inspection center. So entities will proceed to decide. Now this decide, there is two-way by chance. Whenever you want to split entities based on a certain percentage. So if you write here 80% will go for true, here the true, and here the false. So 80% will go to this true, to this side, and the rest, which is 20%, will go to the other side. So if we just put 80% here, and those 80% will go for good, and another 20% will go for bad, and see what will happen. We just add decide. Yani in a bank case, I told you that maybe for the arriving customers, we could have 80% will be regular, and the other 20 are VIP. So you need this decide to split, okay, those VIP and regular ones. And let us have a look what's going on. You see, when you run it for a long time, you will see that the ratio that really that we have 80% here and 20% here. But since because of the randomness, it's if you just run it for infinity, you will end up with exactly 80% and 20%. But here, since we are running it for, let's say, for a short period, which is 5 days, it will be around 80%, and this one will be around 20%. Not necessary to be exactly, not deterministic one. Okay, Shabab? طيب. If I want to split, let's say here, you remember we have a sticker called entity type. This one has a value of mic, and here from this create we have another sticker called entity type, the same sticker, but the value is headphones. So any blue entity will have mic on that sticker, and any red entity will have headphone on that sticker. Assume that I ask you to split. I want head mics to go here. Okay. And I want headphones to go this side. So what to do with the decide here? We just double click here on the decide. Instead of two-way by chance, we choose two-way by condition. Okay, two-way by condition. What will be the condition here? It will be, yeah, there is something already there. It's called entity type. Since we have two types, you just decide on the true value. Here, since we have true and false, who is going to go through the true path, and who is anything else except mic will go to the other path. So since we are choosing mic to go to a true, khalas, this will work fine. So let us just run the model. You see that only blue go on that path, and red are going on the below path. Why? because inside this decide, we put two-way by condition, and this condition based on entity type, the one that we already define under create, and we choose mic to go in the true, and anything else would go on the other side. Okay, Shabab? طيب. Any question? An issue? By doing this, we just answer those two parts. Okay. Now we are coming to a very important point, which is how did we know the distribution for interval time and service time? Yani in real life, yeah, as for you as let's say an analyst, how you will end up with this exponential distribution and this uniform distribution? How we know it? Anyone can help me in that? And in real life, how we will end up with such distribution?
We may use tests for different distributions.
But based on what? You are testing different distribution against what? Yeah, you are right. We are searching for the best distribution, but best distribution to fit what? Shabab. You remember here we said that you have to collect data. Okay, so usually you go and collect data. You observe for the service time. Let's say you keep observing. Okay, the inspector spent maybe now he spent 5.5 minutes on this mic. Next mic took maybe 7.3 minutes. The third mic is taking like 6.9 minutes, and so on. You keep collecting this data, and then there is a procedure to follow in order to find the proper distribution. Once you find the proper distribution, you can use it in the model. Here, you can use it in the model. You end up with uniform distribution as the best fit for your data that you collected from the real system. Okay? Clear, Shabab? Or not?
So you're saying that after collecting the data?
Yes, you have first to collect the data. طيب.
Okay.
How you collect the data? Let me show you. Assume that you are going to here we don't have for service time. Assume for inter-arrival time. Okay, you collected the data. Oh, it's stuck. Just a moment. What happened? Oops. Fine. Here are the data that we collected. Maybe the next mic arrived after 13 minutes, 0.8. Then the mic after arrived after 35.2 minutes compared to this one. Then the next one arrived after 33.3 minutes, and you take this one as a reference. Okay, this is the inter-arrival times. Okay, you collect data. Assume that you collect like 150 observations about the inter-arrival time. Again, we said the inter-arrival time is the time between two consecutive arrivals. يعني هذا وصل عندي قديش أخذ اللي بعده عشان يصل. وصل هذا قديش بعد كم وقت اللي بعده وصل, and so on. Okay, this is called inter-arrival time. This is what we entered here as exponential distribution. Could be exponential, could be anything else. Okay, based on the data that we collect. Assume that you collect the data. Now you want to fit the data into the proper distribution. What you need to do, خلاص, you put it in Excel sheet, put here file, save as, okay, we will save it here as interval times. I choose to use this one, interval times 2, okay. Then you have to save it as CSV file, this one, CSV, or there is CSV, yeah, there is any one of these CSV files will work, okay. So just save it as CSV file. Once you save it as CSV file, there is a tool inside Arena, okay, there is a tool here. We have many tools, by the way. We have something called Optiquest for Arena. If you are doing optimization, if you want to try different scenarios and find the best one using Optiquest, okay, by changing some variables, you can use this Optiquest. If you are doing optimization, if you have some constraints, if assume that some of your constraints related to a number of, let's say, inspectors should not exceed maybe 5, and maybe, yeah, any kind of constraint similar to the OR, okay, you can just do this optimization using this tool. A process analyzer, you can just try with different scenarios and compare it, okay. We have some other tools, but the one that we need here is input analyzer. You can just click on input analyzer. This input analyzer is a tool in Arena that will help us finding the proper distribution. So you just need to open a new project here. Then you need to use existing data file. So you need to import the data that you have, that you want to find the proper distribution for it. So you just click here, then you go where you save the data. I just save it here, and yeah, here, Arena workshop. You remember the one with yeah, interval times 2. But again, the type should be what? Should be CSV file, comma separated values. So I will not, if you choose this Excel file, it will not work. You will choose the CSV file, comma separated value, the one we saved as CSV. Once you just open it, it will give you the histogram of the data. It will show you that, okay, you have 150 data points. What is the minimum value? What is the maximum value? What is the sample mean, sample standard deviation, and all of these informations. By the way, the first step to know the distribution is the histogram. A histogram can give you, is this normal histogram, normal distribution histogram?
No, this is skewed.
Yeah, for sure, this is not normal. But you know, you can also play with this histogram. You can just click here on options, parameters, histogram. You can maybe change the number of bins. Since we have 150 points, what's the proper time? Sorry, what's the proper number of bins or classes?
10 maybe.
We usually said the square root of the n. So it's, yeah, it's correctly around 12. So the software used the right number. We can just make 10. Let's see if we just make it 10. Yeah, it's changed a little bit, but still same. If we make it 13, nothing new. Yeah, I think 12 is the proper one. So you can just play with this one. Let's try 11. So yeah, it's clear, ya shabab, that it is almost exponential. Okay. But how to make sure you can try this data against, let's say, normal distribution, against uniform distribution. Let's try it against normal distribution. It show you that normal distribution, you see the corresponding p-value is very low. What does it mean? We reject or fail to reject? We reject the null hypothesis that this data is following normal. So we are looking to the p-value. So try with Erlang. Yeah, you see Erlang is good. So Erlang is one of the proper distribution, one of the distribution that we can use. You see that also it will give you the parameter of the Erlang. So we just take this one as is and take it to the arena. And here, if I want to do the fitting overall and see the proper fit, the best fit, I can just click here, fit all. It gives me that, yeah, this data is following gamma distribution with this, with those two parameters for the gamma distribution. So you just take it as is, copy, and go here for the arena model and say, okay, the arrival rate, the time between arrivals is an expression, and it's following gamma distribution with those two parameters. Okay, this is how you know the distribution in real life. Clear يا شباب?
Yes, clear.
Fine. And this is a nice tool, by the way. It will save a lot of your time in order to find the best fit. Not necessary for simulation, maybe in other courses. You may need this one. It will give you the p-value using two tests, chi-square test, the one that you are taking in 315, or you already took in 315, and we have Kolmogorov-Smirnov test. Yeah. طيب, yeah, that's it for input analyzer. Okay. So we answered this question from where we find the proper distribution. So first we collect data and we just fit the data into the proper distribution and we take it to the model. Then if you see here, we find that we are not able to reject Erlang even. Erlang is okay. We have a p-value is greater than 0.05, and also here p-value is greater than 0.05. So we fail to reject Erlang. So later, when we come back to our model, and if we find that our model is not conforming to the real system or not behaving like the real system, I may come back and choose another, let's say, distribution, another proper distribution. Maybe if I use gamma and it is not working and I see that there is a deviation gap between my model and the real system, I may use now again Erlang, see if things are improved or not. Okay. Fine. This is again, this is just about simulation in general, but you should keep it in mind. Let's go to the next exercise. Any question, ya shabab, so far?
Clear.
Right. Hope so. Now, in this exercise, we consider two workstations. Workstation 1 for repairing headphones and workstation 2 for repairing microphones. Headphones and microphones arrive to the stations according, this is the inter-arrival time for headphones, and this is this one for microphones. The repair time is estimated to be triangular. So now they have, each one has its own service time or repair time. Okay. After being repaired, the microphones and the headphones are inspected by inspector, and the inspection time is estimated by triangular. So this is both having the same inspection time, but the repair time is different. Okay. But the repair, yeah, repair time, they have two different, let's say, workers to do the repair. Okay. But let us go, and I'm sure that you will forget everything once we reach to that point. So we will go with what we have so far. So we have two arrivals. We have one repair process for headphones and another repair process for microphones. and both after that going to one inspector, and we will see what will happen later. Right, so we need just to open a new file, a new model. So we have to create. So yeah, I'll zoom in a little bit so you can see it. So this create for headphones arrival, and whatever coming from here is the headphone. Sorry, let's I'll use this abbreviation. Okay, and it's following the interarrival time is following exponential distribution with 60 minutes. So yeah, 60 for headphones, and microphones is 40. So yeah, 60 minutes, and that's it. Now for mic arrivals, okay, and whatever coming from here is microphone. It is exponential distributed with mean of 40 minutes. Okay, that's it. Now each one of them will go to different process. Okay, so I need two processes, one for headphones, this process for headphone, headphone repair process. Okay, and again we are talking about cease delay release. We add the server or the resource. The resource is let us call this guy is worker 1. Okay, or operator 1, whatever you want. Okay, worker 1, and the time is triangularly distributed in minutes. What are the parameters for that one? 20, 30, 40. 20, 30, 40. This is a new, let's say, distribution for you, triangular distribution, and this distribution has 3 parameters: the minimum and the maximum and the most likely value. Yani most probably it takes him around something 30 minutes, but minimum will be 20 and the maximum will be 40. No time less than 20 and no times above, let's say, 40. Okay, we are done from this one. Now we have mic repair process. Now this is cease delay release. Add resource be worker 2, worker number 2. Okay. The time also triangular. What are the parameters? 15, 25, 40, 15, 15, 25, 40. Okay. Once now we need to connect this one arrivals to repair and this mic arrival to mic repair. Then later, after finishing repair, we have inspection. So we add one more process for inspection, and this one for inspection process. And this inspection cease delay release, we add inspector. Okay. And what is the corresponding time? Is triangularly distributed with 3, 5, 7. 3, 5, 7, and minutes. Okay. Then all are coming to the same inspector. Okay. Headphones and mics. Let me, from now, I can just change the picture for headphones. It will be again red. Red ball, and for mics it will be blue ball. Yeah. Okay. just to distinguish between them. Then after that, after inspection, on average, 10% of the headphones and 8% of the microphones fail the inspection and are sent back to the corresponding workstation. So 10% of the headphones and 8% of the microphones has to go back after inspection for repair again. So how to reflect this in the model? Easily, we need decide, since we have to split entities into two ways, okay? One for mics and another one for headphones. طيب, we know that 8% of headphones will go back for headphones repair, and the rest will go forward, and 10% from mics will go back to repair. But before we come to those two decides, I need to split mics in one side and headphones in another side, because I need to direct them to the corresponding decide. So if this is the decide for headphones, and this one will be the decide for a mic, I need to split them. How to split them? I need one more decide. Okay, I need one more decide. So what to do with that decide? Now we are talking about the logic of doing a model. You see, now we just connect after inspection. We have to decide, okay, based on type. So I need to split them based on the type. So this one will be two-way by condition. What is the condition? Based on the type. So what is the type? HP will go, headphones will go to true from this path, and anything else will go on the false. Since we only have mics as anything else, so it will go for false. Okay, so yeah, headphones will go to true. So I will just need to connect this one with the corresponding decide, and anything else will go to the other path. Now we can have dispose here and another dispose. This dispose will be for headphones. Another dispose will be for microphones. طيب, now let's go back and see that we have on average 10% of headphones need to go back for rework. So now we split. Here headphones will go on this path. Then we decide on headphones. So 90% two-way by chance. 90% of them will go for true, and the rest will go back, or you can do the opposite. We said 10%. So this is the percentage that will go to true. So 10% will go true. So true will go will go back for not inspection. Sorry, true will go back for HP repair. So true will go back for HP repair. I want this to go up. Yeah, here it is. Right. So why? Because I said 10% has to go to true value. So 10% will go back to repair. What happened to the 90%? To the other 90% will go to false. So this percentage will go to khalas, done from this repair shop, and it will go to store or whatever. Again, we are not focusing on what happened later. What are the other steps? Khalas, it will just leave the current system that we have, which is the repair center. Now for the mics, okay, we said that 8% need to go back for repair, and 92% will be okay. So I can use this decide and say, okay, 92% will go for true, 92% will go for true. Then I have to connect this true with dispose, okay? And the remaining 8% will go back where? Here to mic repair. Again, now this is the model that we have. We have headphones arrivals and mics arrivals. Headphones will go directly to repair process for headphones by worker 1. Then and microphones will go for rework by worker 2. Then both have to go to inspection process. That will be done by inspector, one inspector, and this is the processing time. Then I split them into two types. Headphones will go this side and mics will go the other side. And here I have to decide 10% of the headphones will go through. It means that they need to be repaired again. And the rest 90% will go khalas as good after repair process. And we do the same for mics. Mics, we said that 29% will go for true, that 92% will go for true as good, and 8% will go back for repair. Okay? Any issue here, ya shabab, with this model?
I think it's okay.
Fine. Now, what to do? We need to identify the run length. Here it says, yeah, 5 days again, 8 hours shift, 30 replication. And we are interested in the utilization of the different resources. Let's see what are the things that we can do here. So we go to run here from here, setup. I will just use this as prompt me. Replication parameters, 30 replications, 5 days. It depends on the system. You can run it for like 1 year, 300 days, 365 days, and so on. Based on the system, you can tell. And in some other cases, you may study the system during the rush hour. Yani, if you are talking about gas station, how مثلا hospital or bank, maybe you are just studying the time between 11 a.m. and 2 p.m. So you are talking about only 3 hours only. So you can say, okay, just 3 hours. And there are a lot of things to do there. So here we are talking about 5 days and 8 hours a day, and base time unit in minutes. Again, minutes, you have to decide based on the numbers that you are putting here and there. But it's good to be consistent. Whenever you are using minutes, keep it minutes everywhere. Even when there is something to decide on, I will keep it minutes everywhere, similar to the base time unit. Okay. Now we are done. Let us run the system. You see what is going on. So you see that, okay, after inspection, so there is no interfere between the two different types. Okay. Also, again, this model could be applied to anything. It could be here we have VIB arrivals and regular arrivals. And VIB, they have different track compared to regular customers to the bank. And maybe this inspection process could be the manager, okay? Or let's say any other, let's say, stage, and so on. It's all about how you can think about the model and how to use those different modules to create a complete model without any mistakes. You can see here the ratio, and if you just run it for a long time, we're supposed to observe that 10% only go through this side, and 90% has to go through this side. Here, yeah, 92% should go through this side, and 8% only going through this side. طيب, if we just run it, you see here, by the way, you can track the time. Here you have a simulation clock. It will show you at what time we are now. Here the time passing is 347 minutes, okay? And if you see here, the time is not moving continuously. Time is jumping from one time to another. And those times are nothing but the time of events. Whenever an event occurs, this is how the clock is advancing to the next time based on the time of the different events. Starting service here, finishing service from there, and so on. And by the way, the decide modules, there is no time for those decide modules. Yeah, and here the number of replication. In which replication we are now? We are in the 12th replication now. So we see that, yeah, it's 14, 15, whatever. So we wanted to have it very fast. So we can see the utilization of the servers. Okay, let's see the report. So we can see, okay, let's go to resources. So we have 3 resources, inspector and worker 1 and worker 2. We see that the utilization of the worker 2 is higher compared to worker 1. The inspector is having the lowest utilization. Anyone can explain why this guy having the lowest utilization, even though he is responsible of the 2 types, but each worker here responsible of 1 type? Hi, Shabab. You got the question?
I think if you can repeat it, please.
Okay. Why the inspector, if you go back to the model, the inspector here is responsible of responsible of treating 2 items at the same time. But this worker 1 is responsible of 1 type only. Why do you think that the utilization of the inspector is much less compared to this one and this one? Worker 1 and worker 2.
I think because if you send any item from the 2 workers to the inspector, you will take one of them first, then take the other. So you will do less work.
But you know, the flow is the same. It seems to have flow of 2 items. Any other reasons? I want just to save the time. Look here, Shabab, to the time of the inspector. How long it takes the inspector to finish from 1 item? On average?
I think 5.
5. But look for this guy. How long it takes him to finish?
30.
30. And what about this guy?
25.
25. So this guy, he finished faster compared to those 2. So he will keep free most of the time. This is why, if we go just inside the details. So this is how you just verify again. It's not about just building something and keep it isolated from the data that you enter here. You have to think about everything, the logical, let's say, thinking and the relation between the different aspects. Why I have this result, not that, and so on. Okay, Shabab? طيب. So we have this utilization and it's clear. Let's go for okay, for the next one. Any issue, Shabab, so far? Any question? طيب. If there is no question, we'll proceed. Just okay. So we have this model. طيب, if I ask you that I want the time spent by any, let's say, microphone between this point, let me just add one thing. Draw line, because it's under running, so I have to stop the run. Then I can just edit the model. So I want to draw here a line. Assume the report will not give you everything. Am I right? So it will give you the utilization. If it will give you the, for entities, it will give you the waiting time and the service time and the total time. If you need more information, okay, assume that you want to count how many, let's say, before we go to the time, let's say if we want to count how many, let's say, mics went back for repair. We have a nice module here called record. You see this one, record. You can just bring it here. Okay. So you just want to count how many entities pass through this path. So you just double click on this record. You can put add and you put count. I want to count. Okay. How many or how much to add? If anybody passes through this path, I'm going to add 1 to a certain variable. This variable will be number. This is the name that will appear in the final report. Okay, you add something to the report. So this variable will appear in the report. I will just name it as number of mics failed the inspection and go back for, let's say, repair. So whenever entity pass through this record, this variable will increase by 1. It will keep increasing 1, 1, 1, 1. So you will count how many entities passing through this record. This is what we mean by count. Okay. So once I did it like this, I can just run the model. Run. I'll do batch, so no need for animation. So you see the record, we put it here. Let us see. You will have one more element here called user specified. So once you click on user specified, you will see that you add a counter. This counter called number of mics failed the inspection and return back for repair. So on average, if you just run the model for 5 days, 8 hours a day, this is the average of mics failed the inspection and go back for reward, which is 5.4, 5.5, something like this. 5.5 mics are going back for repair during the run time. Okay. Look to the total number of mics served during the run time. 57. It will be 58, around 58. So can you just divide 5.
How much?
5.5 divided by 58, because the total number served of mics is 58, and we notice that on average 5.5 are going back to repair. You see this one 9%, which is totally very close to the 8% that we have here. Very close to the 8% that we added to the model here. You remember we said 92% will go, and 8% will go back for repair. Okay, don't worry about it. This is not important, but just to tell you an idea about how can you go in depth in your report and in your data. But you need to know when to use record. Okay, this is the first usage of record, to count how many, let's say, entities passing through this path. Okay, the next usage of record is, assume ya shabab, I ask you about the time. Again, I need to stop the run and we go draw. I want to know the time spent by each mic from this point till, let's say, finishing inspection, till this point. So what I need to do, and not this point, sorry, assume that it is till this point because we are talking about mics. Okay, what you can do here, if you want to tell about the time spent between this point and this point for any given mic, all what you need to do, you have to use record here, but this record will need some help from this assign. You remember we said we can add or put some stickers on the entities. I will add assign here, and the purpose of this assign is just to do what? To put a sticker. I want to know at what time that mic just entered to the mic repair process. Okay, I just want to put a sticker there on any mic passing through this path. So this assign actually is used whenever you want to put a sticker onto entity, or whenever you want to change some variables. Okay, so in this case, I want to put a sticker. I will add what you put type, a variable or attribute. We said the sticker called attribute here. So I will add an attribute sticker. And what is the name of this sticker? Name it whatever you want. Name it XYZ. This XYZ is the name of the sticker. And here, what is the value of the sticker? But instead of XYZ, I will name it arrival time. Okay, I will name the sticker arrival time. So whenever further I want to check the arrival time for any mic, I can just pick it up and look to that sticker, and it will give me what is the arrival time of that mic. And in order to, what is the arrival time? It will be the current simulation time, but I don't know how to write it as a formula. I don't know what is the current simulation time. Okay, so we have something called date and time functions. There is something related to current simulation time. We can write just T now. So whenever we write T now, it will give us the current simulation time. So assume that the first mic arrived at time 0. So here at this assign, we will attach what? A sticker called arrival time. What will be the value of that sticker? Will be 0 because he arrived at time 0. Type. After a while, we receive another mic. Maybe assume that the next mic arrived at let's say at 10, or after 10 minutes. So at 10 as a simulation time. So we will put the same sticker with the same title, but now T now will be 10. Okay, so the next mic will have arrival time of 10. So later in any stage of the model, if I want to check the arrival time, I just need to look to that sticker. Okay. طيب. Clear, Shabab, what we did here? We just put a sticker, and this sticker will keep with the entity. Any mic will pass through this assign, will have a sticker, and this sticker has this value T now. So any mic will have all mics will have the same sticker but different values. Okay.
Okay.
طيب. Now at this point here I can use record. I need just record. I can put record here. What will be done by this record? I want to record the time from this point till this point for any mic. So I will use this record and add. Now I'm not talking about count, I'm talking about time interval. Time interval between 2 points. طيب. Now once the entity reach to this, and let me just move it a little bit here. We're talking about this record. We add time interval. Now what is the time interval? I'm looking for the time spent between this point and this point. At this point, I know at what time that entity arrived to that point by something called arrival time, the attribute that I attached there, the sticker that I put on all entities. Now, once that entity moved through this path and reached here, okay, what will happen? The simulation will look to the current time. Assume that the current time is 20. And it will look to the arrival time, the sticker. Maybe the sticker is 10 because it arrived at this point at 10. So 20 minus 10 will be how much? 10. So it will add this time to a new name in the report. I will call it time between, let's say time for repair and inspection. So how long it takes each mic to pass through from this point to this point. Okay, Shabab? And this is just the name. What will happen here under this record? It will look to the current time and compare it with the sticker called arrival time. And how we attach the arrival time, any entity passing through here, we just attach it or put a sticker on it. It will to decide at what time it arrives to this point. And once it reaches to this record, it will compare the current time at which it arrives to this point with the sticker attached to it. So once you run the model, you will see that we will have a new, let's say, tally. What is this tally? Time for repair and inspection. So this is on average the time spent between, let's say, for repair and inspection for each mic, 70 or 71 minutes on average. This is how we use this record. Okay. Again, we use record just to, if we are interested in, let's say, information that is not captured by the report. It could be numbers, it could be times. Okay. طيب. I think just maybe 1 minute for, not 1 minute, maybe 3 minutes or five minutes, and then we will go for a break. Let me just explain when to use assign. This assign, we use it whenever we want to put, let's say, a sticker, whenever you want to change, let's say, the variable. Assume that you are interested in work in process. How many, let's say, entities, how many entities inside the system now? How can you decide on how many entities inside the system? You could create a variable, okay? Variable, name it web. How we are going to let us just, yeah. So I will just create a variable. I will call it web, work in process, okay? And whenever entity enter the system, I will increase that variable by 1. And whenever entity leave the system, I will decrease that variable by 1. So we have, this is very important, Shabab, okay? So we can use just assign. I will use assign here, and I can use the same assign here, and I need assign here to capture the departures. طيب, what to do? So whenever entity arrive here, I will add a variable. What's the name of this variable? I will call it web. Okay, work in process. How many entities inside? It will be what? Web plus 1. So whenever entity pass through this assign, this web will be equal to web plus 1. Okay, and I will do the same here for assign for mics. So whenever mic, I can add one more thing here, variable. This variable called web, work in process, and whenever entity pass through this assign, this will be web plus 1. Okay. Now, what about those two assigns? So whenever we have departure, this web will increase by 1. So here I'll just add variable, the variable already there because I used it before, web. You can use, by the way, any name, by the way, for the variables here, Shabab. You can use any name. Web minus 1 now because we have departure. Now for this assign, we have also, we can just add a variable. We want to change variable web minus 1. Okay. Again, so here whenever we have arrival, when any entity pass through this assign, this web will increase by 1. Whenever we have entity arrive and pass through this assign, the web will increase by 1. Whenever we have departure, this assign will make the web decrease by 1. And when we have departure, this assign also will make the web decrease by 1. For your convenience, I will use the animation so you can see the web actually. I'll just put it here because it's already there. You can see the web. Let me just show you. So you can, okay, let's see. Let's start the model. We have it as batch run. So we remove this batch run and run it. If we want to see the animation, you see, look, here we have departure decreased by 1. Arrival increased by 1. Departure 0. Here 1, 1, 0, 1, 2. Yeah. So you know how many mics and microphones inside your system at any given point of time. Clear, Shabab?
Yes.
Any question? So we see how to use this record. A record is just to collect some statistics that is not presented in the final report. And we see how to use assign. Assign, whenever you want to put a sticker on an entity, like here, if you want to put any sticker on the entity, assume that you want to, I'll show you just a moment. The first usage is about the variables. Whenever you want to change variable, okay, you see the variable, how it changed. And this is the difference between variable and attributes. Again, attributes is a property of an entity as a sticker on the entity, but variables are related to the whole model. Okay, now we have 5 elements. One left 4, another one left 3, another one left 2, 1, 0. Now 1 new, 2 new, and so on. Clear? طيب. Any question, Shabab? An issue? Just one more thing, and we will take our break. Just a moment. Assign, this assign, whenever you want, let's say, if you have, assume that you are receiving patients, okay? And you want to differentiate between critical and non-critical. let me just home, file, new. I just want to show you the concept. So you create, assume that you are patients arrival, and any arrival is patient. Assume that, yeah, you have a certain arrival minutes, each 20 minutes on average you receive a patient, and assume that you have 20% of them are critical and the rest are non-critical. So you need to use decide 20% will go for true, those are critical, and the rest 80% will go to the another path. So here you can use assign here, and you can use another assign for the non-critical. So for the critical, you here in this assign, you can just add attribute, which is a sticker, call it the status, okay, and give it this one critical patient. So whenever you catch later in any process later, whenever you catch an entity and you want to tell if this guy is critical or non-critical, you can just look to that sticker status. Now also for the guys, for the other, let's say 80% who will go for false, here you can just say, okay, add the same attribute, the same name, which is status, but for those guys, NCP, non-critical patients, okay? So those are critical patients and non-critical patients. Maybe both will go for the doctor here, okay? Both will go for the doctor, okay? Now, if both will go for the doctor, maybe later, some of them need, let's say, another treatment. And you need to split them into different paths. A critical patient should be treated first and so on. You can just decide two-way by condition. Instead of entity type, you can just use attribute. What is the attribute? We already add attribute or sticker called status. So when status equal critical patient, take them to this side. When a status is anything else, take them to another side, and so on. This is the beauty of assign, where you can just add stickers to the entities. So later you can use those stickers, okay, or these attributes. Any question, any issue, Shabab? I know that it is too much for you, but believe me, for the guys who are registering the course, if you catch most of the things that we are discussing here, the lab will be piece of cake for you, and the material will be very easy, inshallah.
الله يعطيك العافية دكتور. دحين بريك 5 دقائق ولا 10 دقائق؟
Yeah, let us make it 10 minutes. Yeah. عادي أي وقت بتحب تحط الفورم, I don't have an issue. We will proceed till 10 inshallah. You know, things here, if you just capture all of these things, خلاص, you are fine. You know at least the major modules that you can use in your models, and when to use it, for what purpose, then you are fine. Later, by the way, even if you just finish the course and finish the lab, you will not be able to model, let's say, real life cases unless you go for other, let's say, resources, and you have to search for models, similar models. But at the end, we take the main concept, okay? If you are good in the main concepts and you know the main modules and how to use it, then you are on the safe side. Okay, so let us proceed. I was discussing this module of patient arrival, and we just would decide 20% will go for this assign, and the rest will go to which is 80% for the other assign. And we here put let's say the status. We put just a sticker called status, okay, critical patients. And here we put also another the same sticker name, which is status as an attribute, but this one NCP, which is non-critical patients. You can use the names, the words that you want, but we are interested here in the ID. Assume that both are going to doctors, okay? Here, process, assume that they are going for treatment, okay, inside emergency room. Now, treatment, it will be seized delay release. And here I will add a resource. Assume that we have doctor, okay? Again, if I put here 2, ya shabab, what does it mean? Anyone remember?
2 doctors, you mean?
It means, yeah, you need 2 doctors to treat a single patient, okay? Type. So we need just only 1 doctor to treat a single patient. And here the time of the treatment, it could be anything. Triangular distribution in minutes, could be 5, 10, 15. So minimum 5 minutes, maximum 15. Most probably it will take the doctor 10 minutes to treat any one of those, let's say, patients. طيب, assume يا شباب that for critical patients, the treatment time is different from non-critical patients. What to do? You can put here, instead of regular distribution, you can put expression. And this expression will be nothing but a sticker. So whenever an entity comes to the doctor has to read that sticker اللي محطوط على ظهر الentity. Let us use any name. Name it service time, okay? Service time. طيب. He has just to look to the service time, because non-critical patients, they may need time more than critical patients. فخلاص, you just put here service time. It depends on the entity type, because we have different entity types. We go one step back, and we have to put that sticker for critical patients, and we have to put that sticker for non-critical patients. Here you have to add that sticker on this assign. I will add attribute. I will name it service time, the one that I used there. What is the service time? By the way, it is triangular distribution, let's say, for with some parameters for those for critical patients. So I don't know how to write triangular distribution here. So build expression. You go for random distribution. Where is triangular? Triangular, here triangular. This is how you write triangular distribution, and this is the meaning of the parameters. So I need it as triangular distribution. Maybe he needs 10 minutes minimum, usually 15 minutes most probably, and maybe 20 minutes maximum. Could be maybe 22 minutes. So this is the service time for critical patients. Actually, what we are doing here, we just put a sticker called service time on that entity. Which entity? The entity that is passing through this assign. But what about the other 80% who are passing through this assign to, who are non-critical? I need also to add the same sticker, attribute, the same sticker, which is service time, okay? But this time, maybe their distribution for treatment is triangular with 5, 11, 15 for non-critical patients. They are taking, let's say, less time, but still it's stochastic time. Okay. Now I give those non-critical patients another sticker with different value. Fine. Now once they come to the doctor needs just to look to that sticker, and he can tell what is the time to spend with that let's say patient. Clear يا شباب? This is another usage for the assign.
Clear.
طيب. Now assume that here again we are moving over this priority. If you have priority, if you want to give priority for critical patients over non-critical patients, priority will come where in the queue, صح? So we need to go to basic process and go to the queue. By the way, this is a very important. Whatever we are discussing now is the most important things maybe in this workshop, because now you are familiar of what we are doing and what are the things that we are trying to do. So now we go to queue. How many queues here in this model? We have only one, the treatment queue, and you see that this is the queue. And here you see that it is the type first in, first out, or last in, first out. And also we have, let's say, lowest attribute value, highest attribute value. You can depend on attribute rather than first in, first out, or last in, last out. So I will give stickers. I will give here a sticker for critical people. I will just, this is the third sticker. I'll name it priority. Name it XYZ, name it whatever you want. But I will give them a value of 1. They have a priority of 1. Okay. Then for the non-critical patients, I'll add another sticker, attribute, sticker called the same priority, the same one. Okay. And those guys will be, I'll give them priority of 0. Okay, or any number. I could give them 5, whatever. Okay, 0. For any non-critical, they have a sticker called priority with value 0. For any critical, they have priority of value 1. So when you go to the queue, you can say, okay, you will take the highest or the lowest attribute value. If you want to give the priority for the critical, you should choose the highest attribute value, and we choose the attribute which is priority. So look to the sticker called priority to that entity. If the priority is higher, this entity will come into the front of the queue. If the priority is lower, that entity will go to the back. Okay, so in our case, we just give 1 for critical and 0 for non-critical. Okay, Shabab? So if you want the opposite, you can put here, you can give this one 0, and you can give the non-critical value of 1. Then what to put here, ya Shabab? Lowest attribute value. It means that whoever has the lowest value for this sticker priority will be in front, will be treated first. Okay. Let's just have 5 days, let's say 5 days. Yeah, 8 hours a day. Let us do it 24 hours. This is emergency room, and base time unit in minutes. So you can see what I'm talking about. Oops. Status. This is reserved. It says that this CP is reserved for Siemens. So we need to critical patient. So we need to just to change it. So yeah, where is that? Here we need just to. Yeah, we are talking about which model now? Let me just Close this. Yeah, this one. So it seems that this word is reserved for the programming language. So CRP, I'll call it this one, critical patient. Again, we have another issue, CRP. Undefined symbol. Type, okay, forget about it. So let's go back. Just stop this one. Just give maybe 10 here, and for non-critical you just give number, maybe 0. Okay, so yeah, you see it now. Anyway, at the end we can capture the priority. So this is how you can control the priority in the queue. Okay, who is going to be served first, and this can be decided based on the assign, how many stickers we are putting there. Type. There are some few things maybe we can just show here. Any question, Shabab? Any issue here?
I think all clear.
Type, inshallah. Type here for this model. Now, if we go back, if you remember this model, we have headphones, microphones, and we have inspectors and worker 1, worker 2, and this and that. Assume that you want to put cost for the operators. Okay. So what you can do, you can go here to resources, and you can just put the busy time per hour, how much you pay for the busy hour for worker 1. So assume you pay him $2, maybe for worker 2, maybe $3, and maybe inspector is whatever, and how much you pay for the idle time, and maybe the inspector you pay him per unit. So maybe you pay him $5 per any unit inspected, and those guys you pay them by time. Maybe for idle you pay here $1 and here $1. So either the cost could be by time or per use. So whenever he inspected one item, he will cost me $5. Later, if you want to show this in the report, okay, you have to go to setup, and you have to go to reports inside. Sorry, not reports. Project parameters. You want to show the costs. You can just come here and click on costing just to show the total cost during the simulation run. Okay, and if you just run it, you will have something related to costing. Let us go for batch. This is very fast now, things to know about. Type. So you will see that user specified counter, there is something. It's related to resources, yeah? So resources cost. So you will see what is the average cost for inspector, and what's the average cost for worker 1, what's the average cost for worker 2, and so on. Okay, and also for sorry, this is the usage. Sorry, so this is the cost. I'm so sorry. Here the cost, worker 1, this is the cost, and this is the cost. And for the inspector, this is the cost based on the busy time. We have other options, usage cost. So we have usage cost only for inspector because per usage. Okay, and for those 2 workers based on that time, idle time and Where is the other one? This is for the idle time. The busy time is here. Yeah, here the busy time. Busy time is here. And whenever you want to see the idle time, you can go here. And for the per usage for the inspector, you can bring it from here. You can use this these elements to navigate. One more thing. Now related to failures. Assume that you have here a machine. Worker one could be a machine, or even a worker one could be, if it is a machine or a worker, and this worker is taking breaks. Okay, so you can just identify those breaks as failure. Any comments, any issues, ya shabab? Please let me know.
No, Dr. School.
طيب. Assume that this worker is going for breaks. So you have here from advanced procedures, you can identify a failure mode. Okay, since we are running this one, so you can go for failure. You go for basic advanced procedures, failure. Here, just double click to create a failure. Assume that this failure will be a break. Okay. Oops. So we destroy everything here. A cup of tea just.
إن شاء الله ما جاك شيء بس.
لا. راحت الطاولة. Anyway, but it's not a big deal. So a break. Now the break is based on time or based on count. Yani if he finished like 100 units, he will take a break, or based on time. Usually it happens based on time. So uptime. So what is the time he spent, let's say, working? Okay. And what is the unit? So minutes, if we assume that he spent maybe 60 minutes working, then each 60 minutes he take a break of, let's say, 5 minutes. This is how can we represent it. But usually people are not, yani in systems, it's not like something constant. Okay, it is random for sure. So you can use also, you can say, okay, each normal time with mean of 60 minutes plus minus 5 minutes as standard deviation, he will take a break. And what is the length of this break? It will be uniformly distributed between 5 to 10 minutes. Okay, it does make sense. Yeah, once you create the failure, you can go to the basic procedures and go for the resource. Now you see that this is maybe the worker one failure. You see here failure. You just click on this failure. Somebody is traveling now. Okay. Yeah. طيب. So this is the failure. You just add the failure. We just add the failure as a break. You just add it here. Here, what to do with the entity on hand? Okay, if he is working on a certain entity, what to do? Is he wait till he finish from that entity and then go for break, or ignore it or preempt? We can take you will take the details of these things, or you can easily go to help and see what is the meaning of each one. So in our case, we will say wait. So here, if we just run the model, you will see what is going on. And we don't have animation. Okay. So anyway, so it will not appear here because it is 5 minutes only. It will not appear for sure. But I can just show you some animation about the status of this server. By the way, there are many things to know about here: records, priority, failures, cost. We cover all those three. And sets, this is a big topic. Assume that here you have, let's say, not a worker, maybe you have different workers. Okay, maybe you have 2 or 3 workers. You can identify them as a set. Here, when you add source, you can add it as a resource or a set. If it is a set, you have to identify which set is it. Then from here, we have something called set. If you add the set, assume this one set of workers. Okay. And this set of workers is resources. Now you can just name who are those resources. Ahmed, Mahmoud, okay, and Khalid, let's say, okay. So those are 3 resources, set of workers. So instead here in the process, instead of having 1 worker, you can add, by the way, other workers. If they are all working at the same time on the entity, you can just add them, but you can identify a set of workers. So set of workers, and then you can identify how you want to distribute the work on those workers. Is it cyclical or random, preferred order, or specific member, or smallest number busy? So you can direct the entities to the corresponding, let's say, or to the workers inside that set based on a predefined criteria. Okay, so this is another option to think about. The last thing about animation, this is the last thing, ya shabab, and I know that we have 1 minute only. So from animation here, you can just, again, from drawing, you can draw whatever you want. From animation, if you have variable, you can just, here a variable, and we just use it, this one. This variable, choose the variable that you want, and it will appear. And if you want resources, we have here, what is resource? Here, you just can just click here and add what is the resource that you want. Assume that we want the inspector, and we want to see when he is idle, busy, whatever. We can choose pictures, whatever we want. Then we just bring that one and put it here. Okay. This square will show us when the inspector is busy, when he is idle. When it is white, it means he is idle. When it is just on, yeah, green, yeah, because the processing time is very, very low, you cannot just see it. If you just make this one like 20, 10, 30, okay, you can see it just to show you the status. Yeah, you see whenever it's green, he is busy. Whenever it is white, it means he's doing nothing. Why some? Yeah, very strange. Anyway, but you have a lot of things to do from animation. Okay, you can animate transporters if you use transporters. You can, again, there is a big topic about stations, and we use stations. You will discover this in your lab, so don't worry. I think that's it for today. And please, if you have any question or issue, I will stay here for the coming, let's say, 10 minutes. So if you have any issue or any general question regarding this, I'm here to answer.
Okay, thank you, Doctor. Before any questions, please, guys, I would like to thank you, Doctor, for everything you gave us and your time, of course. Also, I would like to thank Hussein and Abdel Mohsen to help me in arranging this session. So with that, we will close the recording and start the questions if there is any to Dr. Swafi.